In this lesson, we're going to be talking about the difference between even and odd functions. Now, it's kind of like even and odd numbers, but unlike even and odd numbers, we could have neither even or nor odd functions. So we have some very particular examples and definitions that we're going to use. When we talk about finding whether or not a function is even or odd, we're always talking about when we find f of negative x. In order for a function to be even, that means that f of negative x has to be equal to f of x. So in other words, it doesn't matter whether that x value is positive or negative, it's going to be the same thing. Now, the difference here with odd is that f of negative x has to be equal to negative f of x. Or in other words, if I have f of x, if I have negative x, it's going to be the opposite. So let's look at a couple examples. And we're going to talk about making connections both algebraically and graphically. All right, so here's our first example. F of x equals x squared plus 4, and you can see the graph on the right. So first off, take a look. What do you notice about the graph? All right, so I want you to think about that as we're going through this. So we are going to start with f of negative x. So that means we're going to substitute negative x for x, so negative x quantity squared plus 4. Well, if I do negative x quantity squared is the same as x squared. So that's x squared plus 4. So f of negative x is equal to x squared plus 4, which is f of x. Therefore, this is an even function. Well, what do we notice here in the graph? The graph has a very specific symmetry line going through the y-axis. All right, so when we see that symmetry line is the y-axis for a graph, we know that that has to be an even function. Let's look at another example. This time, f of x equals x cubed minus 2x. All right, so let's start with, again, by finding f of negative x. So we're going to substitute negative x for x, so negative x quantity cubed minus 2 times negative x. Okay, well, we know that negative x cubed is going to be negative x cubed, and negative 2 times negative x makes it positive 2x, or plus 2x. Well, I can take that, I can factor out a negative 1. So f of negative x is equal to the opposite of x cubed minus 2x. Well, x cubed minus 2x is just f of x. So f of negative x is equal to negative f of x. That means that this function is odd. What do we notice in the graph? All right, this symmetry line is going through the equation y equals x. All right, so if I look at that symmetry line through the line y equals x, I notice that I can reflect it and I get the same function. Let's look at one more example. All right, so in this example we have f of x equals x squared minus 3x plus 4. All right, well, we're going to do the same thing. Substitute, we're going to find f of negative x. So f of negative x equals negative x quantity squared minus 3 times negative x plus 4. All right, well, let's see here. Negative x squared. So that is going to be just x squared. Negative 3 times negative x is going to be plus 3x, and then I've got plus 4. Well, it's not the same function, so let's factor out negative 1. So that's f of negative x equals negative, so that's going to be negative x squared minus 3x minus 4. Well, that's not the same function either. So it's neither even nor odd, so we just say that it is neither. And then in our graph, what do you notice? It doesn't share either of those symmetry lines. It doesn't share the symmetry line through the y-axis, nor does it have a symmetry line through the line y equals x. So there's two ways that you can verify whether or not a function is even or odd. Checking for symmetry lines, or using that algebra substituting f of x with negative x.